Okay, so it will be a very short session, uh, but this is a very important session because this is almost at the end of the semester. The things are very important. I'm covering only those part that is very important for the final exam. Yeah, I don't know whether you are already informed or not. Today there is a government order, national order that from tomorrow the university classes will be suspended. Uh, yeah, I don't know whether, even though the university will follow their own rules, but it's a government order, so I don't know whether IUT, being an international university, what will be their steps. But anyway, that might be a complexity. There might arise a complexity regarding the lab and the lab final and other things. I'm pretty sure, and other courses also, in most of the courses, the final evaluations are running. Yeah, but I don't know whether you know it or not. But anyway, let it handled by the authority. But why I'm saying, because this is also very important for our. Luckily, we have finished all the class tests, but our lab finals that remains, and we are waiting for Tuesday morning. Yeah, when we need to finish that one. Okay. Regarding the class test 4 marks, I already uploaded that in the Google Drive, and hope you already get the marks. If you find any disputes, please let me know. You can see your scripts and the correct answers is also given there. Right. And I also request you to drop or put your student ID and name in the chat box, in the Zoom chat box. Just as a, yeah, I will consider this as an attendance. Okay, so regarding the today's content, yeah, so just a quick recap. In the last class, till the last class, we have already completed the propositional logic, right? So, sorry. Yep. So we have covered the propositional logic. So this is already done. And the immediate next chapter is called the first order logic. And this is our today's session. Our today's session is first order logic. Now, the good thing is, the first order, this chapter is totally a replica, or it's just the copied content from the propositional logic. Everything is same, almost. Just some minor changes, that is, as I told you in the last class, that is the universal quantifier and the existential quantifier. And I believe you know it, because this is a prerequisite of this course, and this should be covered in the discrete mathematics course. But still, just for the sake of the content, I am covering this part. But remember, I would like to inform you why should we study the first order logic? So what is the motivation? So in the last class, I told you, so the natural language is very expressive, right? This is very expressive. And in contrast, the propositional logic is least expressive. I mean, we cannot express everything using the propositional logic. I told you before. Like, say, somewhere at IUT, there is a, say, yeah, somewhere at IUT, there is a canteen. There is a food canteen. There are many places, but somewhere. So how could you represent these things in propositional logic? And similarly, say for example, everywhere there are students. Say for example, if you write everywhere at IIT there are students. So how could we write these things in proposition? This is really difficult. So we cannot express our idea. All the expressions cannot be presented using the propositional logic. But in natural language, just the language that we are speaking in, like English, Bangla, or natural language, this is very, very expressive. But at the same time, what is the drawbacks of the natural language? This is our natural language is ambiguous. Yeah, I mean, we have to understand the context very clearly. The syntax, the semantics, the context. Still, that is confusing. Even with the context, sometimes that is also confusing. But in the propositional logic, there is no ambiguous. It's said solid, is with proof. So in between the natural language and the propositional language, there is the first order language or first order logic. So this first order logic is both non-ambiguous and also very expressive. Not like that much expressive like natural language, but quite expressive. And that's why we should learn this first order logic. And in fact, we already covered this in the prologue language. In the sessional class, we have covered the prologue, and exactly in prologue, we have written all the statements, the fact, the rules, the clause, everything was in first order logic. Knowingly or unknowingly, we have presented that in first order logic, but I didn't mention that thing at that time because I didn't cover the first order logic at that time. So we just study in a conventional way, in a general way, that this is fact, this is clause, this is rules, and this is predicate. But I didn't mention. But basically, those are the concept of the first order logic. Okay, excellent. So now let me go to the end part of the first order logic. I mean, what is the main question from this first order logic, this chapter? Your ultimate question. So I would like to start with that part. What will come in the exam? Or might come, but with a very high possibility. So as I say, there will be a paragraph like this. This is the knowledge base. And then there is a query. And the query is, West is a criminal. And we have to answer yes or no, or for whatever, true or false. So let me give this is a very common example. This is a textbook example. So let me show you how we can prove it. And how we can prove it, exactly we have covered in the first propositional logic, and that is the proof by resolution. And exactly the same steps we have to follow. We have to follow the same steps that we covered in the propositional logic. And I will show you, and you will see the same thing, except this universal quantifier and existential quantifier. Because in order to represent these statements, this natural language in first order logic, we have to take the advantage of the universal and the existential quantifier. Otherwise, this is very difficult to present, because using propositional logic, we cannot present this. Okay, now let me go through the knowledge base, what it says. So I'm saying again, can you hear me? Am I audible?
Yes, sir.
Okay. So the knowledge base says there are few sentences here. Some sentences are very complex, means connected with some sub sentences. So for example, well, I mean, let me read out the paragraph here. So the law says that it is a crime for an American to sell weapons to hostile nations. Okay, full stop. Saying again, there is a law, it says that It's a crime for American to sell weapons to the hostile nations. So American cannot sell weapons to the hostile nations. So this is a crime. Now the second sentence. The country, Nono. So Nono is a country, and that it's an enemy of America. So Nono is an enemy of America, and it has some missiles. I mean, Nono has some missiles, and unfortunately, all of its missiles, I mean, all the missiles of Nono were sold to it by Cornel West. So Cornel West sold all the missiles to Nono. And this West is an American. Now the question is, West is a criminal. Is it true or false? What is your answer?
True.
Is West is a criminal or not?
Criminal, yes, sir.
Yeah, exactly. So we can easily understand this part. This is fantastic, but well, I mean, we have to prove it. We have to prove it in a not like a well. I mean, it makes sense. Like this is implied. I mean, no implied things will come. I mean, we have to prove it. We have to prove it formally, and that is where the power of the first order logic. So now, what are the steps? I'm straightforward going to the solution. How you should do in your final exam. The first thing is you have to represent all the sentences using the first order logic. For example, sentence number 1. Remember, sir, how could we write this? How could you know how to write this, that thing? Well, you have to learn it. This is a prerequisite. I mean, this will not be covered, but for your understanding, for your if you forgot those things, no problem. At the beginning of these chapters, I will go back to that things. I will flash back to those things after this part. Okay, just for 5 minutes, I will cover the basic parts. I mean, how you should prepare yourself. Okay, the first thing is, say, this is the natural language, right? It is a crime for an American to sell the weapons to the hostile nations. And this is the equivalent first order representation in first order logic. So how? See, for all values of x, y, z, if x is American, y is a weapon, and x sells the weapon y to somebody z, and z is a hostile nation, then x is a criminal. And the same thing. The upper sentence, the natural sentence, and this is the first order sentence. The sentence in a first order logic. The second sentence was Nono has some missiles. So how can I write it? For some values of x, I mean Nono has some. So Nono is someone, right? This is Nono is not everyone. So you see the change. This one universal quantifier, and now this is existential quantifier. So there is some x. Nono owns that x. So what is x? X is a missile. Can you remember in the prologue we wrote in this way? So x is a missile. So this is called a property. Remember what is property and what is relation. So we should know it in the proposition in the prologue also. Like male, right? So say Karim is male. So this is called a property. Property of Karim is male. But brother, Karim, Rohim. So this is called a relation. So Karim and Rohim are brothers. So brother, this is called relation, and one single parameter, then it is called a property. Anyway, so here we can see that x is a missile. So the property of x is missile, and this x has relation with Nono, and the relation is owns. So Nono owns X. Right. So how could you write these things? No has some missiles. Can you see? This is some. And that's why you have to write there is some X. Now, the third sentence. All Nonos missiles were sold to it by Cornel West. So I'm not going through all the lines one by one. I believe you can do it by yourself. Yeah, but if you face any difficulty, surely I'll be there to help you. But again, these are the part of the discrete mathematics course. So at this stage, this is a prerequisite that you should know it. But still, if you are uncomfortable writing the first order logic, say, converting a sentence into a first order logic, then you should do some practice. This is very easy. Just you need some practice. Just I'll refer you some. Well, I mean, I can refer you some online documents there. You can just do some practice and you can do it by yourself. And remember, this is not exactly everyone will write in the same fashion. I mean, the write-up could be a little bit different, right? I mean, okay, I mean, because there are some equivalent. I mean, two sentences can be equivalent. One can write in one way, the other person can write in a different way. But if those two things semantically same, then no problem. Okay, so you have to write all this sentence in the, you can see all the sentences have been written in the first order logic. This is the first step. And now, so see, now the original natural language has been removed. The internal natural language has been, so all the sentences are now in the first order logic. Remember, this is not propositional logic. This is first order logic. That's what I'm saying. See, in every sentence, almost in every sentence, there are some universal quantifier, existential quantifier, and some sentence there is no quantifier, but this is fixed. Like this is West is an American, Nono is an enemy of America, and so, yeah. Apart from these two, others are the quantification with quantification. And now the part of the resolution, proof by resolution. Exactly in the last class we have covered this part. So there are three steps. There are three steps. Step number 1, step number 2, and step number 3. The fourth step is actually implied. I mean, after if you proceed the third step, then automatically you will come up with the fourth step. So can you remember, once we are given a knowledge base, we have to convert it into conjunctive normal form. I spent a lot of time explaining what is conjunctive normal, CNF, conjunctive normal form. So you have to convert this part. And then what we have to prove? Remember, we have the knowledge base, we have the sentence alpha, and we have to prove the knowledge base. We have to prove the sentence alpha using resolution. So what we have to do? So we have to insert into the knowledge base the not alpha. In order to prove by resolution, we have to first convert it, we have to negate it. The query, we have to negate it. For example, it is given that say Nono is a criminal, then we'll start with, it's like a proof by contradiction. We'll start with Nono is not a criminal. And this not a criminal will be added into the knowledge base, and then we'll follow through. And we'll follow through. How we'll follow through? Using the resolution rule. And we will cross out the complementary predicates, one after another, one after another. And at some point, you will find a contradiction. Means, so once you are eliminating using the resolution one after another, very soon you will end up with a contradiction. And at that point, you will stop and say, see, this is a contradiction. That means the assumption you have taken that Nono is not an American, Nono is not a criminal, that is false. So since you have taken that Nono is not a criminal, and that's why this contradiction comes at the end. It can never happen. So your assumption was wrong. What was my assumption? Nono is not a criminal. So that assumption is wrong. So what is correct? Nono is a criminal. So this is how we prove actually. And exactly we do it in the propositional logic. But what is the difference with the first order logic? So the difference is this, only this part, converting the knowledge base into CNF, some two steps, there are some two extra steps are there. What are the extra steps? Because in this knowledge base, there are universal quantifier and existential quantifier. and we have to remove these two parts. We have to eliminate these two parts. And that is what are the extra steps in the first order. And ultimately, this first order logic has to convert into the propositional logic, and then you'll go through. I mean, you will go through the same steps of the propositional logic of resolution. So let me show you. Say, let's start with the first step. Convert the knowledge base into CNF, convert conjunctive normal form. So see the step number one. Step number one. So step number one itself requires multiple steps. So in order to convert a knowledge base into a CNF, remember this knowledge base is a first order logic based knowledge base. So previously we know we have to eliminate the implication, the biconditional elimination. Can you remember? We have to remove the biconditional elimination, move the negation inward, and there are some steps. But here you will see there are two extra steps. So this is the for existential quantifier elimination, and this is for universal quantification elimination. So these are the two steps, two extra steps. Sir, how could you know these things? Well, these are well explained in the at the beginning of this chapter, and that we should know, that you should know. Well, I will explain that one, but this is very easy. And finally, distributivity law, and that we have also applied in the propositional logic. So let's go through an example. For example, let's take the first sentence. So what is the first sentence? So this is the first one. Okay, so forget about the other sentence. Consider only this one. And now we'll convert it into C and F. Similarly, you have to do the second, third, fourth, fifth, sixth, seventh, all other sentences you have to convert it, but do it step by step. So start with the sentence number, first sentence, first sentence from in first order logic, and then go to the second, third. So this is the first one. And what are the steps to convert to CNF? Step number one is eliminate the implication. So see this implication elimination, we know alpha implies beta. How we can eliminate the implication? Not alpha or beta. So exactly it is written that way. See this not alpha or this is beta. Same thing. And then step number two, move negation inward, means De Morgan's law, that we have also covered. So there is a negation here. This is the negation, and we have to push it into the, inward using the De Morgan's law. And that is we have done here. Now, step number 3 and step number 4 is not required here because already there is no need to standardize the variable, and there is no there is no existential quantifier here. So there is no existential quantifier here, and that's why we don't need to see. Is there any existential quantifier here? No. So there is no part here for scholemize the existential variable. So that means we don't need to remove the existential variable. No contribution here. Now, for universal quantifier, yes, there is universal quantifier. And at this stage, you have to remove it. So how can you remove it? Just remove it. But before that, in order to remove it, remember this part is important. Standardize the variable apart. Okay, let me clarify here. What is standardize the variable apart? So if two variables they are same, but not in the same sentence. In two different sentences, they are taking the same variable. Then we have to use a different variable. No two predicates should take the same variable. For example, X is America, X sells Y, the weapon Y to the nation Z. So this X and that X is important because this is connected, right? But see, this is hostile Z. Well, this is X. But if someone write instead of Z, this is X, and this is also X. Now this is a confusing. I mean, for all X, does it mean American or does it mean all hostile? So we cannot keep this confusing variable. We have to standardize the variable apart. I mean, we have to use separate variables for separate universal quantifier. That is what it's mentioning. So at this stage, this is okay. We don't have to do anything because these are two different variables, X and Z. So there is no confusion. So actually, that's why standardized variable apart, there is nothing to do. I mean, this part is nothing to do. Here is nothing to do. So anyway, now dropping the universal quantifier is easy. Just drop this part, and the remaining part you can see, this part is here, this is also here, again same, and see the same thing. Only we have just totally removed the universal part because there is no common variables, conflicting variables. And then perform the distributivity law. Again, we have no need to do any distributivity law at this stage because already this is distributed. Okay. So, right. So this sentence is finally converted into this way after the CNF. So this is the CNF version. This is the CNF version. So this is the CNF version. Similarly, the sentence number 2, this is also converted into this way. And this is the CNF version. Now, here you can understand what is scolemize the variable. So if there is a existential quantifier, and if you have to remove this one, and that is called scolemize. Scolemize means remove the existential quantifier. So in that case, if you want to remove this one, then you have to replace this variable with some constant. With some constant. If you remove this one, then you have to replace the variable with the constant. See, the constant is here m1. Since this one, so this is just like the instantiation. So since we replace it could be anything, not necessarily m1. You can write down here, say for example, p. Say capital P means constant. So in this language, capital P means, well, I mean the Prolog we actually, capital letter means variable, small letter means, well, sorry, capital letter means variables, small letter means constant. But in the conventional approach in first order logic, we say capital letter means constant, small letter means variable. I mean, don't be confused, okay? So this small x means variables, small x means variables. We have to replace it with some constant, and that's why it's replaced by the constant. And this is called scolemization. And this is how we replace this sentence into CNF form. And this is the third sentence. And this is also has been replaced with in the CNF form. We have converted into the CNF form. And again, the same thing, the same and the same, the same. So now at this stage, all the yellow mark sentences has been converted into the CNF. Now, if we, I mean, now if we take only the yellow part, so these are the sentences. So already we have collected all the sentences. Now all the sentences are in CNF form. CNF. Every single sentence now are in CNF form. Now what is the next step? Our query was alpha. So we have to start with the negation, not alpha, and push it into the knowledge base. So that is what we have given. So see, convert the not alpha means the query into CNF knowledge base. Okay. So how do we do this? See, our query was West is a criminal. Oh, sorry, no. So I'm sorry. Our query was West is a criminal, right? This is what is our alpha. The alpha sentence is West is a criminal. Now, since we have to prove it, we should start with a negation, means contradiction, proof by contradiction. We should start with the negation. So what is the negation of West is a criminal? Simply put a negative mark, negation. That is, West is not a criminal. And just add it into the knowledge base. See, the last part, add it into the knowledge base. This part is already in CNF. Just we add this one. and now already done. And now start performing the resolution. So now we apply the resolution. We start doing the resolution. So what is resolution? If you still forgot, if you forgot the resolution, I can recall on your behalf. Say for example, say A or B is a sentence, and not B or C is another sentence. Okay, there are two sentences, and how we can infer from these two sentences? Just remove the complementary part. Just cross out the complementary part. So what remains? A or C. So I explained this with different examples, like if there is a sunny day, or there'll be a class, or there'll be a football match, there'll be no football match, or there'll be a movie show. And from these two sentences, we can come up to this. So I already explained this. So this is exactly the resolution. So this is how we have to follow through now. So now we have all the sentences. Now we will start doing the resolution. So see, let's connect these two one. Sentence number one and sentence, say for example, this one, and say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So the sentence number 8. Now, can you see? Say for example, this is A, B, C, D, E, and this is not E. So if there is a sentence A, B, C, D, E, sorry, A or B or C or D or E, and there is another sentence not E, what we should do? What we could do? Just remove the complementary part. Then what remains? A or B or C or D. Exactly. So now see, this is a criminal X, and this is also a not criminal West. Oh yes, now there is a confusion. So this is X, but this is West. These are not the same. So how could we remove these two parts? Exactly. So that is why what we have to do, we have to replace the variable with this constraint, and that is what we call, see this one. So if you replace the X with West, so this will be West. So everywhere this one will be West, this will be West, and now this sentence will be transformed into this. See, and this is called instantiation. And now these are the two sentences. Now you can cut these two parts, because now X has been replaced with West. I mean, even though this is not shown here, but consider there is no X here. So this is West. And everywhere, this is also West, because wherever X, you should consider West. And we can do this. It is not a problem, because this X means any variable. So just convert it to West. So the West is a constant. It's an object. So now after transforming this part, and now we can cross out the complementary part. And what remains? See, so since these two are cross out, what remains? This one. Yeah, this part is here. This one is here. This one. This one. 1, 2, 3, 4. 1, 2, sorry, yes. 1, 2, 3, and 4. Right? So already from these two sentences, we come up to a new sentence. And see, now just try to see this part. Okay? See, these are the sentence, and this is another sentence. And from these two sentences, we just cross out the part, and this is the new sentence. And now we have to connect this sentence with another sentence. So this is the complete example. Now look at the picture. This is the end result. This is the end result, and this is done. So this is the sentence, and we have already know that West is not a criminal because we start with the contradiction. West is not a criminal. Let's proceed with this. West is not a criminal. And now these two are cross out. These two already cross out. So what it remains? So 1, 2, 3, 4. So these four, 1, 2, 3, 4. These are the fourth part. And now take back another sentence. So what? So how do you know that West is American? Yeah, it is there. You see, yeah, West is American. Just we take this take text sentence. West is American, and now you can see here this part and this part is complementary. This is this is just reverse of one another. So just remove this part, then only this part will come down. See this part, the same thing, right? Now take another sentence, right? Take another sentence, and now again there is a complement part. X is a weapon and Y is not a weapon. See, X is a weapon and Y is not a weapon. But remember, these two are the different variables. We have to, we have to, yeah, I mean, we have to replace the variable X. Um, hmm, yeah. Um, yeah, I mean, it's okay. I mean, yeah, I mean, so these two are different variables. It's not a problem because uh, yeah, so I mean, these are the two variables, but already these two means even though these are the two different things, but since these are variables, so we can easily eliminate this part. So this is not a problem actually. But well, I mean, in order to match these two sentences, how we can match these two part?
Sorry,
Okay.
if we can basically match them with different variables, then what's the point of having different variables?
No. So we have to match it. So see how we can match these two sentences. So this is a sentence. This is a sentence. These are the two sentences. So, well, I mean, this is a separate sentence. Can we write down this way? So this sentence says any variable x is not a missile or x is a weapon. Can we replace this x with y? Is there any problem with this? Just change the variable name. The same. And forget about this part. Don't look at this part. Just look at this part. So this is a sentence. X is not a missile or x is a weapon. Remember, what is x? X is a variable. So can you change the variable? Why not? So you are writing a function. So say for example, integer x, integer y. So instead of x, I can write down p. Instead of y, I can write down q. It doesn't matter. It's a variable. We can change any variable. But remember, we cannot do this because this is x, this is x. If you replace this x with y, then it should also be replaced with y. And also, if you replace it with p, this should also replace with p. That is what I am saying. So now, if you replace this x with y and y, then now we can cross out. Now you can see this one and this one can be, these two can be cross out because this is complementary. I mean, this is one is the reverse of another. So these two can be, we have to, I mean, you can cross out according to the resolution rule. And now this part is here, and this two is here. Is it okay? I mean, someone was questioning this part. Is it okay or not? Or let me clarify again.
Sir, before that, what exactly is the variable doing inside the, like, what
I
does
mean,
missile X mean?
Oh, missile X means X is a missile. And not means X is not a missile. So you are saying, sir, where does it come from, right? Is it your question? Is it your
No, sir.
question?
So basically, to match weapon X and weapon Y, we can replace X with Y because it's just a variable.
Yeah, it's just a variable, but those two are the same variables. If you replace in one place, then you also have to replace in the other place also, because in total, this is a single sentence. This is something like P or Q. So P means this one, Q means this one. If you change something inside P, and definitely if that represent the same thing, then you also change that same thing inside the Q also. So remember, where does it come? Missile X and weapon X. X is not a missile and X is a weapon. So I can go back to the see this one. Answer, where does it come from? Let's go back. This one. Go back. Go back. Go back. Yep, this one. And this is the CNF version of this sentence. So now, if you want to recall, so this is the actual sentence. And what does it mean? For all values of X, if X is a missile, then X is a weapon. If X is a missile, then that is a weapon. And we convert this into CNF form. And how? Because we know how to eliminate, we have to eliminate the implication. Same thing. So A implies B, and this is equivalent to not A or B. So exactly you can see here now. So can you remember now? Can you connect these things? Is it okay or not? No answer. Say no or say yes.
Yes, sir.
Yeah. I mean, so now look at the part. If you instead of X, can we write down Y? Then it will be Y. It will be Y. It will be Y. It will be Y. So it doesn't matter. I mean, we can change anything. I mean, instead of X, you can represent with any variable. So that's why we actually, in order to match with this sentence, because ultimately we have to match these two parts, because we have to cut out something. But these two we cannot cross out these two things, because here X is weapon, here Y is not a weapon. X and Y are two different variables. So we cannot instantly cut out these two things. We cannot cross out these two things. In order to do that, first we have to come up to a single point that both variables are same. So either other way we can do, instead of changing anything from here, we can change here Y. We can write down here X. We can write X. Yeah, that will also work. That is also fantastic. So instead of Y, we can write down X. And then you just cross out the complement part. The same thing. But here it is done in a different way. Instead of X, so first they replace X with Y, and now they cut it. And now these two we can see here, the shorted version using the resolution rule. Okay, so now this is missile, and there is another sentence. And now see, this is one sentence, this is another sentence. Remember, these two are complement. But can you cut out this? Can you just cross out these two things? No, because here is a constant M1 and here is a variable Y. These two are not the same thing. So can you recall the prologue part? So say like, yeah, I mean P of A X is equal to P of Y B. So how prologue match up these two things? Y is equal to A, X is equal to B, and these two things are same. In the prologue, you did it. So exactly we are doing the same thing here. In order to match these two parts, we have to convert the variable with the values. We have to instantiate the values. So in this case, we have to replace y with m1. So as soon as you replace y with m1, also this y should be replaced with m1, and now these two can be removed, and now the remaining part is this part here and this part here. And this way you continue, and finally you end up with these two. See, in the left, Nono is an enemy of America, but in this sentence, Nono is not an enemy of America. So these two are complementary, and we have come up with an empty statement. That means it's a contradiction, and that means that is proved that what we have taken at the beginning, that West is not a criminal, that assumption was wrong. It cannot happen. So definitely West is a criminal. Since your propositional logic background is not that strong till now, because I didn't take any class test on the propositional logic, that's why some of you are confused. But I'm pretty sure you will understand it very clearly if you go through the propositional logic that I have covered in detail in the last 2-3 classes. So I believe this is exactly whatever we have done so far. This is the part of the things that will come in the exam. So I'm done for today. Just to give you a quick well, I mean, yeah, so it's already 40 minutes, 45 minutes gone, so I have to finish. So now I come to the very first, at the very beginning of this first order logic, and you have to go through this part by yourself. If you don't understand, because these are the prerequisite things, as I said, these are the content of from the discrete mathematics. If some of you still confused, and also we have covered it into the in the prologue lectures. So this slide is about what are the good things of the propositional logic and what are the bad things of the propositional logic. I said this is a limited expressive power, and that is why the first order logic, because first order logic we represent using 3 terms: fact, object, and relation. Yeah, so these are the basic things that have been said, and well, these are the very preliminary things. Yeah, and then there is one important thing here: universal quantification. They are introducing what is universal quantification. You should know it. For example, everyone at IUT is smart. Everyone at IUT is smart. How can you write this thing? You have to understand this. So for all values of x, if x is located or x is at IUT, then x is smart. This is how we write. Everyone at Berkeley is smart. But there is a common mistake. There is a common mistakes usually the students do in this way, that for all values of x at x IUT and smart x. Remember, this is not the exact sentence of this one. This is not the conversion of this one. Everyone at IUT is smart. This is not. This is incorrect. This is a common mistake. So instead of implication, you are writing and. No, these two things are different. So why? So what does it mean? Remember, this is wrong. With universal quantifier, remember, with universal quantifier, you cannot write the and symbol. What does it mean? Because it says, what it says? It says everyone at Berkeley and everyone is smart. This is not the same thing as everyone at Berkeley is smart. This is one sentence. Everyone at Berkeley is smart. That is one thing. And everyone is at Berkeley and everyone is smart. That is a different thing. That means all the people in Bangladesh is from IUT and all of them are smart. I'm not saying these things. What I'm saying, everyone at IUT is smart. This sentence, this interpretation, the context, the interpretation of this sentence is not the same as everyone in Bangladesh are from IUT and all of them are smart. So if you write down this way, that means everyone is from IoT and everyone is smart. So this is the common mistake, and that's why it's written a common mistakes in universal quantifier. And similarly, in existential quantifier, usually we write this way, that someone at Stanford is smart. Something like someone at IoT is smart. So we write in this way, for some values of x, if x is from or at Stanford and x is smart. But if you write instead of and, if you write down implication, then it's wrong. And that is exactly this thing. It means for some values of x, if x is at Stanford, then x is smart. This is totally wrong, because yeah, there could be someone is not from Stanford, but as a whole, this sentence is correct. Well, I mean, you can understand this part. Remember, A implies B. So if A is false, then still the whole sentence is also true. I told you before, if this is false, false, or this is false, true, still the sentence is true as a whole. So this is a different sentence. I mean, this should not be the, this is not the meaning what we are saying. The semantics is not correct. Our ultimate sentence was, there is someone at Stanford who is smart. Someone at Stanford is smart. And definitely we have to write down here and, not implication. That is another common mistake. So these are the very two important things that you should know. And well, I mean, those who are still confused how to write these things, I mean, you can go through some of the examples here. Brothers are siblings, siblings is symmetrics, one mother is one's female parent, a first cousin of a child of a first cousin is a child of a parent sibling. So, well, I mean, these are some of the examples. You can practice by yourself if you are uncomfortable. And also, there are a few more examples. Like, you can fool some of the people all of the time. And the other sentence is, you can fool all of the people some of the time. These are very close, these two sentences. But remember, see the position of the universal and the existential quantifier. Yeah, these things are very important. Yeah, that's almost done. And yeah, the other things you can do it by yourself. Remember this unification, that is what we're talking about, replacing the variable with the constant. This is called the unification or the substitution. This is basically called the substitution. In order to do the unification, we are doing the substitution just to make the resolution proof. Yeah, other things are already done. The same examples. It is a crime for an American. The same thing is here. So this is all about the first order logic. This is very important. I already mentioned the question, what type of question will come, and you should prepare it by yourself. And also I will give you some examples in the Google Classroom so that you can practice by yourself before appearing the exam. Any question? Okay. So
No, sir.
okay, thank you very much. Sorry, it's delayed. I was a bit slow in explaining. Anyway, so see you on Tuesday. I don't know about the decision of IoT, whether the class will be continued or suspended. Let's see. But we have to take the exam somewhere. Anyway, I don't know. Let's see. Other than that, we'll meet on Tuesday with the lab final. Thank you very much. Inshallah.